Hey everyone, how's it going? Nice to see you all. It's me and
Happy New Year.
Happy New Year, yeah, by the way.
Uh,
We're back strong. We are going to kick off this intermediate Firebase series. I hope you're psyched for that. We have a lot of things prepared for you. We have already 3 workshops planned, including this one. And we have a lot of stuff to cover. So yeah, Raf, do you want to touch on what we're gonna see today and maybe in other events as well?
yeah, so today we're going a little bit in depth into Firestore and how to do some complex querying. Um, the code itself is a little bit nitty-gritty, but we're actually going to explain the concepts behind the scenes and like how we are chaining these queries together. And then next week we'll have a look at analytics. So we'll make a demo cart so that you can add products to the cart, and then you can determine which users have added products to their cart, who's purchased items, and then left the site. And then the next week we'll go into some cloud functions, and that should be very exciting.
Yeah, exactly. Like we've been improving the code up until like the start of this event. For the lack of preparedness, this is going to be very interesting because we will figure out things as we go as well. Um, I would love to show you what features we will be developing today. Raf, like let me know if we can do that. If we can just show what we have, that if that's possible.
Yeah. Firstly, should we show the differences between what we had before and what we
Yeah,
have
that'd
now?
be great. Could you share your screen? That's
Yeah,
fine.
perfect.
Cool.
So if I have a look at the e-commerce with Firebase website, this is what we had previously. Each category themselves only has the shoes, and it queries all of them all at once. And so what we want to do is structure this in such a way that we can limit the amount so that if a user comes on and they find what they're looking for immediately, then it will only pull the first few shoes. And then we also want to give some options to do sorting and filtering, and eventually we'll do searching as well. And so these are the changes that we've made right now. So in this case, when a user logs on, it only pulls the, sorry about this, it only pulls the first 4 cards. Um, so this is a bug that we have. We will
You
work
might
on
you might need
fixing
to
it.
resize the screen. So we wanted to achieve something similar to what social media websites have when you have infinite scrolls and it pulls down
Yeah.
posts as you go, like below the what you've already seen. So yeah,
And so now that you can see we have the scroll bar, as we scroll, it then pulls some more products and loads automatically. So
yeah,
it's a little bit buggy right now, but that's an opportunity for you to help us on this and maybe push a couple commits.
exactly. So we're gonna explain like the theory behind this and how this is supposed to work. Uh, really rely on you as well contributing and maybe helping us out developing the features for this project. Um,
Exactly.
yeah, should I jump into explaining that or?
Yeah, sure. One other thing, just quickly, we've also got this nifty little range finder that allows you to choose which
Right.
prices you're willing to look for. And then you can also sort by price from lowest to highest. And then you can also sort by name. And then another thing to mention is that we've got these queries kind of compounded on each other. And so it'll always only pull the first X values, depending on the size of the screen. And so even if you're sorting, you're still going to limit the amount of document reads and writes. And that's important in Firestore because you're not actually being charged for the size of the data that you're requesting. You're being charged for how many times you're requesting data, for how many document reads and writes you perform.
Exactly. And it's very important to optimize for as minimum of document reads as you can do. And this is something we will come back later on in the presentation. You want to optimize, you want to minimize your document reads, because that's the most common operation that your users will do. They want to read your documents, view your pages. And if you can minimize the number of reads you do, you will get more space available for you to do operations in your Firebase account.
Yeah, and just so everybody knows, you have a maximum of 50,000 reads per day before Firestore will start charging you, or Firebase rather.
Yeah.
So 50,000 per day reads. Okay.
Okay, let's just jump straight into presentation and have a high level overview of what's happening in the app. Yeah, if I can, yeah, that's perfect. Thank you. So yeah, intermediate Firebase. So we want to kick off this series with just showing you how to structure your queries with Firestore. So in the today's event, we will be looking just high level what's filtering is about, querying is about. We will be looking specifically at filtering and sorting your queries. So if you don't want to get the whole collection as your result, you want to filter out based on some search parameters or sort them by some parameter in your collection. We'll look at pagination and what that means. So Raf already kind of demoed this dynamic loading of documents. You will see that it's being achieved, it's achieved differently in different applications. You will either get a lot of pages you can click through, or you will get that dynamic loading of documents. And then we'll actually look at the code that is behind our application and see how we can improve it together and how we can contribute to the repository. Then we'll have a Q&A session if you have any questions. Yeah, by the way, feel free to drop any questions either in YouTube comments, we'll respond to that, or there's also a Discord channel outside the Valley, which you can join and ask questions there. We'll answer in both places respectfully. So as in the intro events, we'll go over some terminology before kind of jumping into code. So the main buzzwords that you will hear in this presentation are queries. So queries, the method of you talking to the database, basically. When you retrieve documents, you query those documents. Sorting and filtering, those are quite common. I think might have some understanding of what sorting and filtering is. Pagination is a nice concept to keep in mind. If you don't want to fetch your whole database table, you don't want to fetch your whole collection of documents. You only want to show a set amount, only the number of documents that the user needs to see. Indexing is another important concept. This is basically how Firestore structures and stores your data inside on the backend. And this is actually why Firestore is so fast. If you want to retrieve a document, Firestore actually keeps a lot of indexes and a lot of optimizations to retrieve the document as fast as possible. We'll go back to indexing, and I'll explain why it's important when we hit some limitations with Firestore and things you cannot actually do to some extent. Document reference, document snapshot, we've heard these in the previous Firestore event. These are basically some Firebase specific coding terms. They're used to represent your reference to your document. So that's not actually the data you get, that's the reference to the database, like to the place in the database where the document lives. Document snapshot is just the snapshot of the document at a given time. So it's like the state of the data and its metadata at some point in time. And then we'll also look at a query snapshot. A query snapshot is a state of a query at a given time. So what that means is like it's going to return only a set number of documents as its result at that point in time. All of that a bit later down in the presentation as well. So before we begin even going into any concepts with querying, I want to explain two important JavaScript concepts that you might already heard about, but they will be heavily used in this presentation, so that there are no questions about this. Or if you want to read more, there's good articles about spread operators and conditional chaining. Just a quick overview of what that is. So the spread operator is basically these three dots you can see before the A variable. So let's say you have some objects with some basic properties and values, and you want to include an additional property to that object. And you want to store that in a new, fresh object to work with. So basically what you can do, you can spread the values of the existing object into the new object and also add a new field. So the resulting object will contain the ID and also all of the fields of the starting object. So that's called spreading. You're spreading one object into the other. You'll see this in a couple of places in code later on. Conditional chaining is another very cool concept. The basic idea is that if you have a chain of accessing a parameter, some parts of the chain might not exist. They might be undefined, null. So as you can see here, the starting object doesn't have the sizes array. So when we try to go a.sizes.hasMedium, JavaScript will throw an error. It's going to say that sizes is not defined, and then you're like trying to access hasMedium from undefined. It's bad. But then you can use this question mark dot syntax, which basically means that I don't care if this exists or not. If this exists, great, just fetch me the value of a.sizes. If it doesn't, it's going to return undefined. So even though there's no a.sizes.hasMedium in our starting object, we will not get an error in response. We will just get undefined. Like this just doesn't exist. Pretty cool trick. Saves you from a lot of if statements that you don't need to check for every step in your chaining process. And this was introduced actually quite recently. This was a feature that was requested for a long time, and pretty cool one to have in your JavaScript tool set. All right, so that's, if you have any questions about that, feel free to drop them. We can go over this again and explain this in more detail. Let's start going into Firestore API and looking at how we can retrieve data from our database. So as you might recall in the previous workshops, we already touched on db.collection, db.doc, how we can add documents, remove documents, reference, list the documents from some collection. In this event, we're introducing a new function we can call. This is .where. And this is a very powerful function when you want to filter something out. If you don't want to receive all the documents that get back to you from the .collection call, you can chain a .where, specify some conditions of what you want it to be returned, and then it will return only the things you need. So in this example, you can see that we have 4 documents with different prices. And like easily enough, I can say that give me all the products from the collection of products where the price field is less than or equal to 200. So you can see that it only took the price 50 and price 150 in the resulting set. Pretty good, pretty nifty way. So let's break this down. So the first, where accepts 3 parameters: the property you want to filter on, the condition you want to filter on, and the value you want to basically provide to the filter. The first and the third one are pretty obvious. You can control them however you want. The second one, you have some options. So for the second one, for the second parameter, you can do your regular equalities, so less than, greater than, less than or equal than, and so on. There's also, so the next example, I think, yeah, shows array contains. Array contains is a very cool way to check if a given value is inside the array defined by this property. So you can see that we have sizes as defined as arrays for each document. And we want to check, we only want to get the documents that have the M size in it. So we can say sizes array contains M. It's not going to return this document which doesn't have M inside sizes. Let's see, what is a good thing to point out here. First thing is that in case your document doesn't have sizes whatsoever, and this could happen, right, because we're using a NoSQL database, that document will be filtered out by definition. Like it's not even going to be considered inside the query. So where will only return the document that contains the sizes and the sizes property, and that sizes property also lies under this condition. Something important to keep in mind to make sure you include all of your documents contain the property you are filtering on.
And then just a question. So if we want to search for not just the large. Oh, we've got a question. DB is the instance of Firebase, Firebase.Firestore.
Yeah.
So we're just using DB as a reference to the database. So we're saying database.collection, but really what we're saying is Firebase.Firestore.collection.
Exactly. Yeah, this was probably a good thing to include in the slide, but yes, thank you, Raf. And we'll show that inside our code as well. We'll kind of reiterate on that.
But so say, for example, I wanted to search for large and medium. Is there an OR operator that I can use to pass in an M or an L?
Yes, there is. Actually, there is an interesting thing. There's array contains, but there's also array dash contains dash any. That operator actually accepts an array as a second parameter. So if you want to include all the documents that have the sizes of small and medium, you can say sizes, array contains any, and then pass an array of small and medium. So it's going to match an array to array kind of style. Yeah, but thanks for the question as well.
And then if you guys have any of your own questions as well, keep them coming. We like to engage. We want to hear from you, and it also helps us, know what we're skipping over. Maybe if we like going too fast, anything of the sort.
I'm actually gonna I'm gonna show some examples here, but then I'm gonna probably dip into the documentation for Firestore just to show all the options that are available. So yeah, let's move on to the next example. So we have, if let's say you want to order your query, you have a bunch of documents with different names, and you want to alphabetically sort your documents in your collection. Once again, you can say db.collection and then order those documents by the specify field. Nothing too extraordinary here. Once again, the order by query will only consider the documents that have this name field. If I would have a fifth document that doesn't have name and only has price or some other data, it will not end up in the resulting set. Something to keep in mind. Otherwise, pretty simple. You can specify a second parameter in here, which is descending, DESC. We'll see that in our demo. That will basically just give you your list of results in descending order. Then there's pagination. So we've talked about this for a bit at the start of the event. Let's say I have 4 documents, but really the good use case is when you have like thousands of documents. Let's say you have like a lot of posts you want to show on the screen. You don't want to query the whole collection. You want to limit your collection to some number of documents that only fit on the screen. And then when the user scrolls down, it's going to load another, like more documents for you. So the way this is achieved is by this .limit function right here. You can specify whichever query you want and then chain a .limit that's going to return the first 3 or the first n documents that you query. An important thing to keep in mind as well, like you could chain, if I wanted, I could chain a .where and then a .order by, but there is specific cases and specific rules you want to chain these things on. I'm going to go over some limitations of Firestore and what you can chain, what you cannot chain and combine. For example, the first limitation is that you can only specify .limit if you have an order by query. So I could not go and say db.collection limits 3. Firestore just doesn't know what you want to order by. It doesn't have a notion of ordering by ID. It can order by name, it can order by price, or by any other field that's in your products collection, but you have to specify at least one order by for every limits query. Yeah, let me know if there's any confusion here. The next thing we're going to look at is the start after. This is the crucial part when you do pagination, because you want to load 3 documents, let's say, and then you want to load the next 3 documents, and then the next 3 documents, and so on. The way this is done with Firestore is you keep the reference of the last document you load, and then you load the documents that start after that document, and so on. So that's basically your whole process. We're gonna see this in practice in the demo, but in this example, I'm ordering by name, ordering my products by name. I'm starting after some hat document reference. So this variable is, it's basically should be maintained by you in code, in your client code. And you can see that I'm going to start after this document, not including the hat document, and I'm going to limit my query to 3. So what it means is that all of the documents that are to the right of hat going to be included in this query, and I'm only going to take 3. Just because there's only 1 document here, that's what's going to end up in the results set. So you can already see that here's your pagination, right? We rendered the first 3 documents in the first query. Then we might just save the document reference to this last document in the result set, and then render the next document in here based on the last document that we already saved and maintained. It's kind of confusing to hear this the first time. Kind of, you would think that this should have just been built in, but when you actually like build this out and write the code for this, it's pretty organic, and it doesn't. If you have good state management in your apps, you shouldn't have any problems. This is quite a difficult concept and a cool feature to include in your application. So if you have any questions, please make sure we can help you to figure this out, or if you have any confusion here, we're always free to help.
And there's also an important one, because this is what's going to save you some money in the long end. If you've got 1,000 items in your database, you want to be implementing some kind of a limit so that you're not requesting all of them every time a user comes on.
Exactly. Let's say like you have 100 documents in your collection and you have 10 users that are always refreshing your page. You don't want to render all 100 documents for every user. There's going to be a lot of document trees that are going to blow up your limit in no time. If you just limit to the first 3 documents and then only show the next 3 when the user needs to see them, that reduces your document reads significantly. So that's a very important point to keep in mind if you want to optimize for document reads. Let's touch on some limitations of what you can, what chaining functions you can combine when you do your queries with the Firestore database. So the first limitation is that I've already mentioned this. Order by filters out documents without the order field. Yeah, like if you order by name, it's not going to include the documents that don't have the name property in them. Something very important. This is a source of confusion when you have 10 documents in your database. You try to order them, and then you get like 5 documents in the database. That doesn't make sense, right? You didn't filter anything. But a very important thing to keep in mind, it's gonna filter out the documents that don't have the property inside them. The second limitation is that when you combine the range filter and the order by filter, you cannot do that on different fields. So that's the first example that we show here. Unfortunately, you cannot order by name, but then also filter out by price. If you're combining a where and an order by query, they should be on the same field. This could sound like a kind of weird limitation. Why would Firestore limit you on this? But an important thing to keep in mind is that you need to structure your database so that it's easy to query. It's the reason Firestore cannot do this query is because of the way it's indexing its fields. If there's for each property in your document, there is a separate index that Firestore creates, and it's going to create an index for price and an index for name. And it's only going to perform fast queries on one type of index. There are ways to overcome this by creating compound indexes and other complex things, which we unfortunately not going to cover, but feel free to explore that. But this is like one of the main limitations. You cannot have a .where and a .order by on different fields. The third limitation is combining range filters on different fields. You cannot filter out by different fields as well. Like I cannot say that the price should be larger than 300 and the stock should be less than 20. That's kind of a compound query at that point. You could create separate fields where you combine both of those price and stock fields and then filter out by that. But unfortunately, you cannot chain those two .wheres on different fields as well. And this is something I've already touched on the order by. On the limit and the start at. So both start at and limit clauses should be preceded by at least one order by clause. So what this means is that we cannot write something like this. We need to have at least one sorting clause, the order by function, to determine so that Firestore knows how to sort your fields first. After that, it can do whatever you want. It can start after any document, it can limit it to whatever number of documents you want, but you need to specify which field you want to sort by. This is actually all the theory that I had prepared. We have a question coming in. So what does less than or equal to or greater than mean? So less than or equal to or greater than, those are operators. Those are basically saying that these are your Boolean comparison operators. They're saying that this price field should be larger than 300 or less than 300. Less than or equal to 20. So these are the conditions on which all of the documents should specify to end up in the resulting query. So if we go back to this example right here, price, if the price is less for each document, if the price field is less than or equal to 200, that's going to determine that the document is correct and it should end up in the resulting query. And you can see that in here, price is less than or equal to 200, and same for the fourth document as well. Those are the two that end up in the resulting query. So I hope that clears that out. Yeah. I wanted to kind of quickly show you the documentation and all the types of different, where you can find help for this, first of all, like references you need to look for, and also all the different options you have. So I'm going to go to the documentation real quick. So if I type in firebase.google.com, I'm sorry for my slow connection, but we should get here anytime. So if I go to docs, and then I should be able to select web in here. So on the left-hand side, that's all of your different services that Firebase provides, and what we are looking for is Firestore. So we have Cloud Firestore right here, and I want to go into this read data section. Let's go into order and limit data. Actually, I probably want to, be here. So yeah, if you have any issues or you want to look up on different options or limitations you have, like Google documentation is pretty awesome. I like to always just read through it. If I don't understand something, go on Stack Overflow, ask some questions. It's a great resource to go to. So let's see. Here are all the options for the .where query. So we've shown less than or equal to. There's also just equality if you want to. Array contains any is what I was explaining when Rafa asked me the question. There's also in and not in. Let's actually take a quick look at these. So the inequality comparisons, they are pretty similar, all pretty similar. They just define different Boolean operations. These four last ones are pretty tricky. So array contains, we've shown that, but yeah, like your array contains operator will filter out only the regions that as an array they contain West Coast. There's also array contains any, where you can specify different options. That's basically like your OR query that Rafa was asking about. Not in is like similar to in this case. I want to, in and not in queries. These basically check if the value of country is one of the specified ones. So if the country is equal to USA or the country is equal to Japan, then it's going to end up in the resulting query. And this is actually array contains any. Sorry, I was confused there. But then the regions, if it's an array, it could contain any of the values in here. That's why the name is array contains any. These are pretty fresh, by the way. Firestore didn't have array contains any until quite recently. So also to the point that Firestore is always developing its queries, always improving its query language, and I quite like that. Cool. Yeah. So if you have any questions, feel free to ask anything that you're confused about, or just reference the documentation, read about it in here. It's a pretty great resource to go to if you have, if you don't.
Andrew, just one more thing. If we can find in the documentation the caching functionality. So we haven't implemented the caching functionality right now, but Firestore does allow you to download data and keep it inside your website, in your web browser's cache. And then that allows you to access the data offline, as well as, say, for example, you want to search through the products that have currently been loaded. Instead of having to pull them all at once, you can use that then.
I'm not too sure what you're referring to, because we did not include that into the project. But is this something?
Yeah. Unfortunately, I haven't looked into it enough to be able to talk about it during the event in depth, but it is something that is available to those power users out there.
Yeah, we might explore this in a future event, but yes, this is definitely an option. Your Firestore queries will run offline, and if you want to enable, there is a way to enable persistence in that sense as well.
I'll have a look, and if I can get the link to specifically that documentation, I'll drop it in the chat.
That'd be great, thank you. All right, let's look at let's look at an actual example. This will be very, very close to what we have in the demo, in the upcoming demo. I want to talk about this example specifically. So this is like top to bottom real life code that you will get, that you will write, and this is how we structured our code. Sorry, I just took a sip. So let's just go line by line and see what's happening here. So first of all, you have your collection reference. I can get any collection I want. I can do a sub-collection reference. This is basically the starting point of your querying. DB, yes, probably we should have included where DB comes from. DB, as Rafa mentioned, is basically your Firebase.firestore call. Is going to be just available for you, and we're going to show where that comes from in the demo. So on the left-hand side, you can see I included some pointers to different types of data that is being returned, and this is very important to keep in mind as well, because when you do these calls, you need to understand that it's not always like simple objects that are being returned to you. And you need to understand what functions you can call off of them and what exactly are you working with. So db.collection returns a collection reference. Pretty self-explanatory. It's a reference onto your collection. You cannot yet access the documents of that collection, but you can construct a query after which we will execute the query and get the documents after that. So your step number one is get your collection reference that you want to query. Step number two is construct the query and basically do your order bys, wheres, limits, what have you. Step number three is actually execute the query and then work with the data that you receive. So let's go step by step. So step one is we get this collection data into this query variable. Now, has name ordering and has page limit. You can imagine that this would be wrapped in some kind of a function. And whoops, sorry, didn't mean to do that. Has name ordering and has page limit are some parameters that we would pass into that function. And let's say if we want to order by name, then we would modify our query. We would say that the query is equal to query.orderByName. Similar to here, to this example, has page limit also determines if we want to modify our query to limit to like 5 documents. So this is just some hard-coded examples. You might have something more sophisticated in your applications. Let's have a look at the types that are being returned. So as I mentioned, query is a collection reference to start with, but then the order by and the limits and .wheres and all of the querying operations and chaining operations that you execute, they will return a query object. A collection reference is awfully similar to query object, but they're a bit different. Both of them will return. You can execute both of them, and they will return the documents at that point in time. There are some small similarities. I won't go over them, but in general, you could almost treat them as the same. You could chain .orderbys from both query and collection reference. And it's just something to keep in mind. Even though you're building your query, you're working with this query object. And once again, like maybe I even show this in documentation later on. I'll show where these types come from. So when we've built our query, depending on our parameters, we can now execute our query. You will note this await keyword. This is because .get function that executes the query is actually an async operation, meaning that it takes time to do this, right? Because it's going to fetch the documents from your cloud, from your Firestore, return those documents. That takes time. It's pretty fast, but it still takes time. It's not instantaneous. So I want to await until this completes. And what we will get back in return is a query snapshot. And the query snapshot, I've mentioned this in the terminology. Query snapshot is a state of your query at that given point of time. So that's all your metadata and all of your data of your documents at that point of time. Now, I cannot just operate on this because query snapshot is like, it's some abstract blob. I don't know what to do with it. I can get the documents from it. So if I do query snapshot.docs, that's going to return me an array of query document snapshots. Very similar to document snapshot. Query document snapshot is almost the same thing. Returns a state, like an array of states of every document. What I really want is just to get an array of objects, right? Like I just want to get my array of products that have my price, my name, my whatever I specify in my database. So to convert an array of query document snapshots into an array of objects, I would need to call my document data function. So you can see that I'm mapping over each document in the docs variable. And for each document, I'm returning a new object. I'm returning an object that contains the ID and also spreads the data of the document. Let's look deeper in what's happening in here. So this is coming back to the spreading operator. Doc.data will return just pure data that's contained in this document. So if I have some fields, some values, that's going to return me a plain JavaScript object with all of those key value pairs. Now, I don't have an ID of that document, and this is something very important to keep in mind. When you retrieve doc.data and you call that function, it's only going to return the data, none of the metadata about the object. And an ID is considered to be a metadata property. So this is a very important difference between an object and a query document snapshot. Query document snapshots contains a way for you to retrieve the data and also some extra information. So what we're doing in here, we're creating a new object. We're including the ID as a document.id, and we are also including the data. So in the resulting object, we will have this flat list of all the property keys that are in our documents in the Firestore, and also the ID property. This is quite useful. Maybe you need to, I don't know, list all the documents and reference them by IDs later on your website or in your app. But you will see this in a lot of places, like people spread the document data and also include the ID in the same object. So that was a lot of words. There was a lot of things to kind of sink in, take and remember. If you have any questions, please feel free to ask them. I'm gonna go over this again, but this is like the basis, the structure of the code that we're gonna show. How are we doing?
We have a really good question. We've got a question about the map. Okay. So, if you don't mind, Andrew, the map function is essentially replacing what you would have to do manually in a loop, for example. So your .docs will return you a massive array, and then what you could do is you could do a for loop that has a look at each individual element in the array, and then you could say that element .data, and then you can add that to the object that you've defined somewhere above. But what the .map is doing is skipping through that process, and it's saying, I'm going to look at every single element inside of this docs, and I'm going to map it to a individual doc, and then I will return that value.
Exactly. Let me actually show an example. I'm going to quickly pull up a console.
Oh yeah, that's perfect.
Do this here. I hope you can see this. So let's say I have an array here of some values. And what I want to do, I want to get an array of like 3 times each element. I want to perform an operation on each element in this array and get another array in return. So the array I'm aiming for is like 3, 6, 9. That's what I'm looking for. So what I can do is I can do a.map, and then for each element in the array, I can return, let's do a compound function. So it basically accepts a callback that defines your conversion. So you can, for each element in your A, I'm going to return E multiplied by 3. That's going to return me 369. So it's like very, very similar to what we were doing here, because for each document snapshot, this loading, for each query document snapshot, we want to convert this into an object. So this function defines the conversion logic. It's saying like, take this element in the array of docs, and then return me something new, something I want to receive for each element in the resulting array. And that's basically the definition of what we are looking for. It's a very, like, so there's .map, there's also .reduce and .filter. If you haven't heard about it, I highly recommend you touch on those three functions. There is a quite important. Map is not, I'm not entirely sure if I understand the question. Map is just pure JavaScript, like.
I think that they're asking if it's, sorry.
It's not something like .map is not a function you call of a specific object. Like it's just pure JavaScript. It's you can call this on any array you want. Okay, I hope that clears that out. Thank you for the questions, by the way. If you have anything else you want to, you're uncertain about, you want to ask about, we can cover that. What are we thinking? I could go into the, it's basically like demo time, or one other option, I could go into the documentation and kind of show the types. I don't know, we're kind of short on time. Maybe we show the demo, and then if we have enough time at the end, I'm going to dip into documentation again.
Yeah, I think that it would be nice just to give people an opportunity to play around with the code themselves. Mm-hmm. So if you do not have the website already, I'm going to drop the link in the chat for the repository. And then you can clone it into your own project. So here is the link to repo. And then if you do have the repository already, where you want to be is in the event for Firestore queries branch. So if you're looking to check out branches, it would be git space checkout and then event for dash Firestore queries. So I can put that in the chat as well.
Yeah, that'd be great. Thank you.
Did you want to, so while I'm doing that, did you want to go into the code, or should I?
If you have it open, I think it's easier if you do it. I can pull it down as well. It's
I do have it open. So then would you mind just putting the command for checking out the branch in the chat? So if they do have the repository, they can check out the correct branch. And if they don't, sure. They can just clone it and still check out the correct branch.
Okay, so I'm gonna pass it over to you. We can go over the code together.
Is everything big enough? Please just let me know if at any point it's too small for people to see.
A bit, like maybe we can increment one more time. Yeah, that's great.
Okay, cool. So I think the first thing that we should look at is just the HTML. So just explaining how everything is kind of laid out. We have got a column for sorting and a column for filtering and a column for searching. And so just to show inside the actual website, So this is our column for sorting, this is our column for filtering, and this is our column for searching. And what's important here is to note that these are going to be triggering our functions. And so when we look at specifically the value sort, which is the sorting by the price, like if you want it to be most expensive first or least expensive first. So what we're doing is we've got this reusable function. And if you've seen our first Firestore event, you should be aware of this function, the get products. And it essentially takes in two parameters. And it is the product type that we're trying to get, and then any options that we're looking to get on top of that. So let's have a look at that for a second. One thing that we did do as well, for those of you jumping in now, we documented all of the code pretty thoroughly. So if you are looking to jump in, this will give you an understanding of what the function does. And then we've got the parameters as well. So if you are a little bit confused as to what parameters to pass in, you can always just hover over and it should give you a little bit of documentation. But
sorry, Raf, not to interrupt you. Which branch exactly are you working with right now?
This is event 4-Firestore queries. But the developer branch would be just as good.
Okay, cool. Yeah. Perfect.
Yeah. Okay, so what we're doing in this get product is we're basically looking for all of these different filters to see how we're going to build up our query. So the first thing that we do is we check to see if the price filter has been passed in. So this itself is a map. And here we're using this really cool question mark dot, which is going to give us back a undefined rather than throw an error again. And so this is going to be useful when you've got maps that are not always defined. So we've initialized it here, and they do have initial values. But for example, when we want to search by sort by price, we don't want to be sorting by price and also sorting by name because of those limitations that Andre mentioned earlier. And so this is an instance in which we will be taking the sort by name property on the options and we'll nullify it. We'll say it's equal to null. And so that when it does come a time that we need to check if sort by name exists, we've got this operator that's going to allow us to fail gracefully. What we're doing here, this is just every time you click on the sorting, it will flip the value. So if initially we're sorting upwards and you click it, it'll then flip it downwards. And then it will change the symbol corresponding. And then the same thing is true for the name. And then over here is where we're defining the actual sort by price object on this options. So we're looking inside the options and we're saying, okay, well, we know that we want to sort by price, but now we want to decide whether or not we want it to be descending, whether or not we want it to be sorted up or sorted down. That's the same, the whole process is done the same for when we're sorting by name. So we've got three things that we've spoken about. We've got whether or not you are filtering by the prices. We haven't touched on that just yet, but I'll get back to it in a second. But we've got filter by price, we've got sort by price, and we've got sort by name. And then once we have all of these options, we can then go ahead and actually get our filtered products. And so what we're doing in get filtered products is we pass in the type. This is the reason that we had that little bug at the beginning of this session, is that if we're basically using the styling framework Bulma, and we're trying to say if the screen is smaller than a certain size, then we'll only show 2 cards. And so to demo this, if I put this as an iPhone, for those of you who haven't yet used the developer tools, it's really useful. You can hit F12 and that will bring up the developer tools. And then you can also change the size of your screen. You can see the outputs. But for us, this is useful because we've actually logged the options that we're choosing. So initially, we've got a price filter, which is undefined because we haven't touched the price filter. We are sorting by name off the bat, and we're not sorting by price. It's there. I think we might be. But what I actually came here to do is show you that we've got 2 products retrieved because it's a small screen, so we've only loaded 2. And this is what we were mentioning earlier, that it really saves on database reads, because maybe somebody is going through your database and all they want to do is just browse real quick, and then they find something they like, click on it, and now they're back to what they want. So instead of having to read maybe 100 documents, you might only need to read 20. And this is what that function does, is it just determines how many documents do we want to pull to fill up the screen to the minimum real estate that lets the users see everything. And so in the small screen, it's going to pull 2, but in a big screen, it's going to pull 4 off the bat.
Raf, could you like real quick touch on the code that handles the scrolling, because it's going to pull more documents when you scroll to the end of the page, right?
Yes.
Every
So
piece of code.
that function is in the main.js, so it's kind of nifty. Is the code big enough, Andrew?
Yeah, that's good.
Okay, cool. So yeah, so just to go into the how that works itself. So we have got a function load product on scroll, and we're just looking for whether or not this window has been scrolled. We're checking to see if the actual height of the window plus their scrolling value is equal to the offset height of the document body. In other words, if they've scrolled enough that the addition of the scrolling plus the screen real estate is equal to the whole thing, then it'll be true. And so we know that we're at the bottom of the page. And what we've done over here is we don't want to keep on scrolling and loading documents forever. We only want to keep loading documents till the end of the documents in the database. And so this is a max document reach flag, and this will stop the scrolling function from loading when there's no more documents, when the database has pulled all the documents. And so if it's not true, if we still have more documents, we're going to, again, load more products. And this is another function. Right underneath our get products function, there is a load more products. Similar situation. We're getting filtered products, again, the same way that we do in the old function. And this time, we're just passing in an extra option. So we've got like this options parameter, which allows us to configure really as much as we want. And again, we're using the spread operator to combine the current options that we have. So let's say we are sorting by name and we're filtering prices. This will allow us to load more and keep those options intact. Super nifty use case for the spread operator. And then just to show in the console, so we've got the inventory size for the category. And this is useful because soon we're going to touch on cloud functions. And we'll show you how when you add a new product into your database, it will increment this count for your inventory size. So stay tuned for the cloud functions series.
Exactly. Could you, sorry, Raf, to interrupt again, but could you go into the Firebase console just to show where that comes from?
Oh yeah, for sure. So we're right over here. Can everybody see? Is that big?
That's good.
Okay, cool. So over here, when we want to look at our shoes, we have got an inventory of shoes, and this is because of the way we've structured our database. We've got a document of shoes. So shoes technically is one document, but it has a sub-collection which contains multiple documents. So these are the actual shoes, but over here on this shoes document, we've got the inventory size. And so this would be a good place to put other items like maybe what is the cumulative value of your inventory? So like how much money do you have tied up in all of your shoes all together? Or maybe which shoe is being sold the best. So you got like maybe a best sellers list, something like that.
Some statistics
Yeah,
for the shoes as well.
exactly. And so this is a really good use case of having your nested tree structure with sub collections, because we can still get some like metadata essentially about the shoes in general, but we also have all of our shoes all at once. And so what we'll do in 2 weeks time is we will explain how can we get this number to turn to 18 when I add a document over here. Or subsequently, if we delete one, how do we get it to turn to 16? Because it's not as simple as just making a read and write. You have to perform some calculations, but if you can do it using a cloud function, really easy. Okay, so we touched on the loading more products. So that's one of the options that we've configured, and that's what we call as pagination. And then just to show that function in action itself, that is over here. So we went over to the results per page, and that's going to do our limit queries. This is what's getting how many products in the inventory. But here is the real brains of the operation. We've got a lot of ternaries, so if you're not comfortable with ternaries, it's okay, we'll go slowly. But they really do save a lot of space. So our base query, we're looking at DB again. It's the database. And we want a collection. Because we're in a sub-collection, we must have 3 parameters or 3 parts of the slashes. We're in the inventory. Okay, so now we check, are we sorting by price currently? Does our options contain the sort by price flag? If they do, then we can structure this query. So we're just going to check now if we are descending or if we're not descending. And this is something to notice as well about the order by function in Firebase. When you do order by, you only pass the descending flag, DESC, if you're looking to descend. You don't pass ASC or ascending if you're looking to ascend. You just pass nothing. And so we're checking, are we sorting by price and we're descending? If so, then this is the query that we want to add. So we're saying query is equal to what it was plus this. And we're going to descend it if we're not descending. So if this statement resolves to false, then we're just going to order by the price ascending like. The same thing is true. Yeah.
I hate to do this again.
No, do it.
Yes. I think this is a good place to show where the DB parameter comes from, because I know you were asking where DB was coming from. So yeah, line 17, you can see that it's Firebase.Firestore. It's basically the same way you access any kind of services from the Firebase object. So the Firebase object comes from the CDN you include in your HTML file. And you can do either .auth, .analytics, .firestore. Basically gives you an access to a particular service from Firebase. And DB is your root entry point to your Firestore database.
So, I mean, theoretically, we could always just say firebase.firestore ... Exactly. But this is just to make it a little bit more readable and more traditional in a sense. So that you can say like database.collection or database.document.
Yeah, thank you.
And please, Andrew, step in. I need it.
Absolutely.
So we touched on the order by query. The same thing will be true for when we are sorting by name. So I know that it's going to be a little bit confusing since, we configured this to say sort by, but Firebase actually says order by, but, kind of the same thing. But again, we're asking here, is the sort by name flag, firstly, we're saying, is the sort by name there? Is it not null? Is it not undefined? Is it there? Is it a map? If so, we'll go in and we'll actually configure the query. And so we'll say, is it descending? If so, we want to use this query. And if it's not, then we want to use this query. So I know this can be kind of confusing, especially when you're looking at it for the first time. So if there are any questions, please drop them in the chat. And then this is really cool as well. This is our price filter. And so what we're doing here is similar to this. We're checking to see if there is a price filter. And if there is a price filter, we're looking to see, is it a minimum filter or is it a maximum filter? So do we want all the items that are cheaper than a certain value? Or do we want all the items that are more expensive than a certain value? And so here we're using the .where command. This is another query command that comes from Firebase. And in this case, we're looking at a specific field again, the price. We're using the greater than or equal to operator. And then we're actually getting the minimum price from here. And so just to show you what that looks like on the site itself, if you should probably make this a little bit bigger. But anyway, so say, for example, we want to search for all the products that are greater than or equal to 150. So the minimum price must be 150. And then maybe let's make this a little bit less. Yeah, we'll do like this. And then we'll change this again, make this maybe like that. And then that will load these products for us. And so over here, you can have a look. We've console logged all of this. And if I can make my console just a bit bigger, this is our configurations. Whoops. So here we're seeing that we are loading more. So the load more is true. We're not sorting by name. Whoops. We're not sorting by name. We are sorting by price. So we've got this price filter, and we've got a minimum price, which is 95. And we're not sorting, we are sorting by price. And this is another thing that Andrew mentioned to me when we were making this, is that when we do a query like this, where we're trying to find values less than or equal to a certain number, we actually need to sort it by some value. So Andrew talked about this a little bit earlier, and that's that if we're saying that we want to look for anything where a price is greater than or equal to, or let's say less than or equal to, we need to order by a certain field. And so the way that we've done this in the code is that on our slider, no, this was in this code, actually. So here, this is our filter by minimum price. So when we're filtering by minimum price, we're passing in the product type because all of our get products requires a product type. And then we've got this little options map. And we've got the price filter. So it's minimum price. But we have to pass in some sorting parameter. We have to say, give me all the values where the price is less than 20 and sorted by price. So that's something to remember as well.
Another thing to point out, I'm actually not too sure if this is required to also have a sort by. You might, if you take out the descending false, it might also work. But another thing I wanted to point out is if you go back to the Firestore JS file, we do a compound where query. So you can see that we're doing a where on line 43 and a dot where on line 47. And it is very important that those where queries are on the same field. So this is a pretty hard limitation. You don't want to combine dot wheres in different fields. And you will see that if we have both min price and max price included in our price filter, this will work because the dot where chaining works like it is operating on the same price field in the document.
So we couldn't, for example, say, fetch me all of the shoes where the price is greater than 5 and where the brand equals Nike or something like that.
Yeah, exactly.
So that would just be something that you have to make a design choice about on both your front end and on your database structure.
Yeah.
So we've talked about the price filtering, the sorting by name, and the sorting by price. The last thing is to do the pagination. Andrew, would you like to talk about the pagination?
I can jump in if you. I'm going to kind of drive you through this.
Sure.
So here, what we're doing is basically we're keeping track of the last document that is being rendered on screen. And this is actually being defined before this function, I believe. If you scroll up, we should see the last document being initialized to null by default. And that's because like we don't know what the last document is. We didn't yet render anything. So if we go back to that conditional, what we're essentially doing is we're checking if their last document exists. We want to start after the last document. So this provides us with that pagination functionality. We want to render only the, like if we're loading more documents, we want to load documents after the last document provided. I think the next line where last document is, yeah, like if the next line where last document is being referenced is, I believe it's 65 actually. So if we're not loading more, documents, the last document should be null. That means that if the last document is null, it's going to just run, it's going to render the documents and get them from the starting point of the collection. If we are specifying that load more parameter, we do want to have the last document being started at we want to get the query being started after the last document. And then on 72, we're updating the last document to whatever the actual last ending document of our snapshot is. So
and I think one thing that's just, sorry again to cut you off, but it's the type of last document that's important. It's not a number. So do you want to talk about that for a little bit?
Exactly. Like snapshots, if you see where a snapshot is being defined, it's on 69, it's await build query. So that snapshot is actually the query snapshot I was talking about in the slides. And when you get the documents from snapshot.docs on line 72, that is pretty much the array of query document snapshots. So I can go into the documentation and kind of show the difference between these types. But yes, Raf was right that last document is of type some weird Firebase type, which you need to keep reference to. It's not a simple object. It's not a number or anything like that. It's not your actual last document. It's the reference to the last document in the database. And the way you update it is you get the snapshot docs, and then you get the snapshot docs length minus first document of that. That's how you get your last document.
And one thing that I think that's really neat about these query commands is that we've actually chained a lot of them together depending on what the options are. And so we've got query is equal to query dot. So essentially what we're doing is, if we've got a limit function, we've got dot where some stuff, and then if we're ordering by, we've got dot order by, and then if we are limiting the amount, we've got the dot limit. Wait, in fact, we've got first start after, and then we've got dot limit. And Andrew, also you mentioned to me how important it is to have the dot limit after you use the start after, correct?
Yeah, well, it's actually the limitation. One of the limitations is to have that order by before start after and dot limit. So you need to order your query by some parameter before doing start after or limit. You can use either one. So you could do a start after without a limit, or you can do a limit without a start after. The key limitation is that you need to include at least one order by per every start after or limit.
Okay.
You need to order your query.
So sorry if I confused you a little bit earlier, but yeah, so what I'm just saying, 100%, you need to have your data ordered in some fashion before you can tell it, start after this value or limit it to these values.
Exactly.
But this is really cool. We've been able to chain multiple different filtering functionalities, and essentially what we're doing is we're chopping this up as the options tells us to. So if the options says, we're not looking to order the data, gone. If we are, it's there. And once we have all of these built up, that's where we actually get the data. So here we're looking at the snapshot, we're awaiting the query. So the query is what we've been building up this whole time. And then we're using the dot limit one more time. And that's going to give us a limit of the results per page. So that was that function we talked about a little bit earlier. If it's a small screen, it's going to give us 2. And if it's a big screen, it should give us 8. And that would give us a small screen, it would give us 2 rows with one card per row. And if it's a big screen, it'll give us 2 rows of 4 cards per row. And then we just use the regular good old-fashioned .get, and .get is what's going to give us back those document snapshots, the array of document snapshots. And then we just return that snapshot over here. And then over here, we again use the map operator. And what we're saying is, for every single document in the snapshots, we want to look at the individual document at element I, say, for example. So this would be analogous to saying docs at position I. So doc is equal to docs at position I for every single document. And then we're going to combine the ID of the document with the data of the document. ID is super useful because we need to be able to click on the product to take it to the next page. And I think, if I'm not mistaken, that's most of it. Andrew?
Yeah, I think that we covered the most of it. This was like a lot of things, and our code is far from being ideal. If you have, we really look into refactoring this and making this better and more readable. So we really encourage any suggestions that you guys have, or basically anything you all want to improve about the code or the code base. Highly encouraged, and would be nice to have some pull requests going if you want to contribute to an open source repository.
Yeah, and some good experience, and we get to build some relationships. I would say that Andrew, you and I, of the last 2 months working on this, we started building a pretty decent relationship, and it would be nice that we could expand that into some of our other DSC fellows and maybe even just regular enthusiasts.
Of course, yeah, like the Firebase community, and just it's nice talking to people who know Firebase and like know the technology. Um, it's always nice to have a cool conversation about it. Um, yeah, I think let me just share the slide. I don't think we will have enough time to go into docs that I wanted, but let me just quickly share the slides with some improvements that you can do um, on the application, and then we'll just open up for any questions that you have after the event. So if we can show the slides on the presentation.
Do you want me to share, Andrew?
I am sharing my screen. I'm just not sure if it's on the live stream. Cool, thank you.
There we go.
These are like the three main things we identified. We've talked about the limitations of Firestore and that you cannot combine some different filter combinations. For example, I could not filter out by price and also order by name, right? Because the basically the fields will be different for the order by and the where clause. But there is different combinations you want to include. So maybe I want to sort by name and also sort by something else. So if you can come up with some sort of a combination that will work for our application and you want to have that improvement, that'd be great. Any UI improvements are welcome, always welcome. If you want to style a little bit better or improve something, make the cards a bit nicer, always a good way to contribute. Search functionality, you've seen the search field kind of lingering around in the app. We didn't kind of include that because, to be honest, search by keywords is not the greatest power of Firestore. You need to look for some third-party solutions there. But on the other hand, you could implement search for just client side. What I mean by that is when you get the products, you could search in the actual resulting products you got from Firestore. So if you can figure out a way to do that, that'd be great. I would love to talk about that later on if you have ideas. And yeah, these are just the three key points to kind of lead you in the way where you can improve the website. But in general, any improvements or anything you notice that where our code is far from being ideal, you want to rewrite something, feel free to kind of drop a pull request. We'll have a look at it together. It would be a cool way to just engage and talk to you.
You can also, engage on the Discord. There has been a couple questions been coming through on the Discord, so that's another place. If you have an idea for a new feature that you'd like to implement and you're not 100% sure how to implement it, you can always just send us a message on Discord and then we'll walk you through that process of how it could be implemented.
Absolutely. Yeah, I think this is everything we wanted to cover. It was a lot of information for you all. If you have any questions, feel free to drop them in the YouTube comments right now or in the Discord. We will be in the Discord all the time. You could ask us anytime you want. Both me, Rafa, and Dalton will be more than happy to help and assist you with anything you have, any problems you will have in the setting up the project. Yeah, maybe we give it maybe like 30 seconds. I'm gonna check both the chats and the Discord, and we'll wrap up after that. Cool. Thank you, Claire.
I don't think there is. Let's just plug ourselves for next week. We have got the analytics. So
yeah,
again,
next week is exciting. Next week is actually going to be pretty different from the events that we've been running, like the last 2 or 3 events.
Yeah. And this is going to be like more business oriented. So if you've got business friends or even marketing, this is going to be really good for marketing because we're going to talk about the Google AdWords platform. So if you've ever searched on Google and you've seen a little ad pop up there, we'll talk about that and how you can optimize those ads for specific products in your website. Say, for example, you know that all of your shoes are being added to the cart. You can optimize ads for shoes, or specifically a single shoe. And so we're going to show you how to collect all that kind of data. And then the following week, we're going to be doing the cloud functions, correct?
Absolutely, yeah. So cloud functions will be a cool way. So Ralph kind of touched on what they could be used for, maybe listening for your documents in your Cloud Firestore collection and updating some other values, or even like some third-party APIs or whatever you want. Basically, the power of functions is that you can call them and then they can do whatever you want in your Google Cloud setup. Send an email, update your Firestore collection, send a pops up message to a topic, or even do something with analytics. Like, possibilities are endless, basically, and we're going to touch on some different types of functions and what you can, what use cases are out there. And yeah, in my opinion, like, the topics we cover are the most powerful, both like Google Clouds and Firebase solutions and services that you will find just yourself using them more often than other services are, in my opinion.
And I think Cloud Functions is specifically one of the things that draws people to Firebase above many other backend services. It's really quite useful and powerful.
Exactly, and we'll see how easy it is to set up as well. So
that's another thing, super easy to set up. Yeah,
really excited for that.
Me too. All right, so stay tuned, everybody.
Cool.
See you then.
Yeah, and, see you in the next one. Thank you for joining.
Have a good weekend and week. Bye.
Bye.
Get ready for a cloud-first workplace. Jumpstart your career by signing up for a Google Cloud hands-on learning experience. Companies around the world are moving to the cloud. This is a unique opportunity to gain new skills and professional credentials. If you want to discover a career, scale your startup, or perform groundbreaking research that will change the world, this is the event for you.